Hello everyone, today we will explore some interesting paper called Language Model of Few Short Learners. This paper is from OpenAI, and as you can see, a lot of people worked on that. And basically this is the paper that presents GPT-3, which is a language model with 175 billion parameters. And in addition, they explain how we can use a big language model to perform other tasks besides the language generation without the fine-tuning phase. So let's start from the basics. What is a language model? So a language model is a model that, given a context, for example, this sentence right here, we want to predict the next token or the next word. So let's say that we have a language model, and then we take this sentence as the input. And then the model output a probability for each token in the vocabulary. So usually we have like a really big vocabulary, something around 50,000 tokens. And then in this case, most probably the index of the word that marks the word trend will be with the highest probability. Okay, so then we do a argmax and take this index, and then we treat the trend word and the new word that we just predicted as a new word in the context. So we take that as the context for the next timestamp, and then the model should predict the next word, of course, here in this situation, the towards. Okay, so this is a language model, but GPT, to be exact, is a autoregressive language model, and it's based on transformers. So what does it mean? So basically, transformers, the main component in transformers is multi-head attention. So we have the tokens, and then we want to output a vector representation for each token. In the multi-head attention component, we can really condition each token on all of the other tokens. But in autoregressive models, because autoregressive is mostly used for language generation, so in this case, in autoregressive, we can really condition each token just on previous tokens and the same token. Okay, so in this case, we can do, when we output this vector, for example, we can condition all of the other tokens, but when we output this vector, we can condition only on the first and the second tokens. Okay, so basically, when we want to use this pre-trained language model, so there are two phases. First is the pre-train, when we have like massive data sets, and then in self-supervised manner, which means that we're just creating our own label. We train this model to predict the next token, and then after we have like these massive pre-trained models that was trained on massive data sets, we can really add some new set of parameters, for example, some feed-forward network, and then this layer will output one number that, after a sigmoid or a function that will transform that to a probability, we can use a threshold to understand. For example, let's say we want to perform a sentiment analysis task. So it will output a probability, and then we can use a threshold to say when it's 0, when the probability is below the threshold, it will be 0, and then when it's above the threshold, will 1. 0 meaning that the sentiment is negative, 1 meaning that we have a positive sentiment. And for that setup, we really need label data for the sentiment analysis. So let's, for example, take the IMDb reviews sentiment analysis task. So we have a label data with IMDb reviews, and we just retrain this model to perform this task. And the authors say that there are several downsides for that setup. So first, although the fine-tuning phase really need like less data, less label data than the pre-training, it still need like between 1,000 to 10,000 of examples, and it's really, this requirement is really hard for many tasks. It's really hard to collect large supervised training dataset. And second, they're saying that there is evidence that suggests that generalization achieved under the paradigm can be poor because the model overlay specific to the training distribution. This means that, for example, in the IMDb review, so the model will perform really good on the IMDb review, maybe will reach state of the art, but when we have like different sentiment analysis task that is different, the data distribution is different from the IMDb, the model will perform poorly because it's really specific to this task, to this data set. And third, the argument that say human is not, so it's like human against the machine, so human can generalize good with tiny number of demonstration and don't need like large data sets, and this is not really the case in deep learning. So what they are suggesting is basically, so here's their approach, and they're saying, okay, there is the fine-tuning approach that we just talked about, and they're saying that this work we do not fine-tune any GPT3 model because it's not the goal here. And they have three other setups: the few shot, the one shot, and the zero shot. In this picture, they are really describing these approaches. So in the zero shot, we have this language model, and we feed it a task description in the prompt. So we have this language model, and we have the input, right, the context. So here we have like the task description, and we ask the model to translate English to French, and we give it the cheese word, and we expect that when we have the vocabulary, when the model output the probability for each token in the vocabulary, the most probable word will be the translation for the word cheese in like the French, in French. So this is the setup for zero shot. One shot is the same, but we are adding example. So here is an example: English translated to French. And in the few shot setup is really the same as the one shot, but we just have more examples. Okay, so and they're comparing that to, if we are comparing that to the fine-tuning approach, so the fine-tuning approach, we have like this label data set, and then we are really retrain the model, we do a gradient update, we change the weight, and this approach, what they're suggesting is not really changing any weight, we just, this one is in the inference phase, we just checking what is the output of the probability for the next token. Okay, so basically they conducted some experiments, and the result is we can say that there is two conclusions from the results. First, when you increase the number of parameters of the model, the performance also correspondingly increasing. So this is consistent in several setups. For example, here the trivia QA is a QA task, and then we have like translation task. So the performance of the success metrics is increasing when we increase the parameters, and it's not really depending on the specific task. And the other conclusion that they have is that I think that they are saying is that when we increase in the number of example, but when we give in the context, so the performance also increasing. So let's jump to the conclusion. So basically they are saying that they are presenting a new language model with 175 billion parameters, GPT3 of course, and they are describing 3 setups: 0 shot, 1 shot, and few shot. And in the next video we will check the conclusions. That first they are saying that when we adding more parameters to the model, the performance, we have a boost in performance. And for example, when we add context, when we have more examples in the prompt, we can boost the performance also. We'll check that using GPT-3 on the sentiment analysis task, IMDb reviews.